Okay, now we should have finished at least 1 through 4, or 1, 2, 3. And what you should have been able to do is to list these times in this table and then look at when these times hit 80 degrees Fahrenheit, or approximately 80 degrees. So you are able to back calculate the amount of hours after death by looking at your table that the student might have been passed away if we checked body temperature and it was 80 degrees. Now when you plotted the graph up at the top and you looked at the graph with your classmates, you should have thought, well, obviously this wouldn't actually keep going forever and ever. So I'm going to ask you now to think about what would happen. Would the body eventually freeze? So if you didn't finish 3, ask yourself, like, what is the trend of the graph that you made from the table? Does it keep going? And is it realistic that it should keep going? So those are the kind of things you should fill in number 3. Once you've done that, if you haven't completed that, Mr. Dines will pause the video. If everybody's completed this section, what you should have realized is that this is limited because obviously the person's not going to freeze to death. They're going to be limited, at least by rule of thumb, by the temperature of the room. Now, this number 4 and number 5, what we're going to look at is we're going to see how good this rule does against actual data. So in number 4, you have a table of an actual person where they looked at the temperature in the body hours after death. And over here in this slot, you're going to put what you get by the 1.5 rule. Now the data was presented in multiples of 3 hours after death. So you wouldn't pull in all from your table, you'd only pull in the 3, 6, and 9. And in number 5, you'll also pull in 3, 6, and 9. In number 6, you'll be answering whether you think your model has done well by looking, or the 1.5 rule has done well by comparing it to the actual data. And then you're going to go back and see what happened if the person had a 90 degree Fahrenheit temperature. How long would they been estimated as being dead by looking back at your original table, and ask yourself if that makes sense. So again, in number 7, you're going to really look at the data and see if it's overestimating or underestimating the time of death, and draw what you think would the real curve would look like in comparison to the curve that you've graphed with the line. So I wanted to show you a couple computations just so you can see what these looks like. You would put in, for example, here the 3-hour time of death, which you calculate by getting the temperature at estimated temperature at 3 hours, not 1 hour, but 3 hours. Notice here again that the data is presented to you in multiples of 3. So if you have any questions, Mr. Dines is in the room so he can answer them for you.